Somewhere by a hydrothermal vent deep, deep below the sea, there lived a Siboglinid colony.
My little Siboglinid, I think the time has come for you to learn about your history, our history, of who we are and where we belong.
I know we're deep-sea tube worms that lack a digestive system. Isn't that all we need to know?
Oh, you're silly, but knowing your history and taxonomic arrangement is important. Why don't you tell me what they've been teaching you in school? What do you know about us?
Well, I know our home can be 10,000 meters deep in the sea next to hydrothermal vents, methane seeps, or even whale bones. We have a big family that lives in large cluster colonies with tubular chin homes fixed to the ocean floor. I especially love how we have a closed circulatory system and a developed nervous system, but no digestive system. We also have an extremely unique excretory system that allows us to live in environments that enable us to exploit differences in food, sulfide, and methane availability.
Very good. You're so smart, but there's still more. I like to think we're quite mysterious. Where to begin? Years ago, when I was a wee little Siboglinid, I didn't know where I belonged. There was much debate about the evolutionary history of Siboglinidae. Discussion after discussion, from the fossil record to cladistic analysis, our placement in the phylogenetic tree was tricky.
So what's the big picture?
I'm glad you're paying attention. The big picture is that the Siboglinid evolutionary history is hard to understand.
So what did they do about it? Did they make a hypothesis?
An article titled New Perspectives on the Ecology and Evolution of Siboglinid Tube Worms aims to address how and when our ancestors evolved into obligate endosymbiotic Siboglinid species that we are today at chemosynthetic ecosystems. In other words, how did we end up like ourselves way down deep in the ocean? And in case you didn't know, a chemosynthetic ecosystem is specifically places that are high in methane and low in oxygen, like the hydrothermal vents or cold seeps we call home. To accomplish this, the scientists wanted to observe our morphological, genetic, molecular, environmental, and fossil data to see how these evolutionary leaps occurred.
So, Grandma, if there's not much information about our identities as Siboglinids, what exactly do we know for certain about ourselves and our origins?
There's no need to worry, my little worm. Although there are still many unanswered questions about our kind, researchers have worked very hard to discover some key characteristics about us that can help us begin to better understand our evolutionary history. In fact, they have made 3 important observations about our history in recent years.
What kind of information did they find?
Well, sweetie, the first finding is that adult Siboglinidae lack a gut, mouth, anus, and conventional feeding ability.
What, Grandma? If adult Siboglinidae don't have a gut, mouth, or anus, how do we consume our nutrition?
Excellent question, my little worm. Well, the fact that adult Siboglinidae don't have digestive systems has sparked many studies about how our ancestors obtained their nutrition and how that relates to how we obtain our nutrition today. One hypothesis suggests that we have dissolved organic matter uptake across our body walls that allows us to maintain nutrition. A study conducted by Kavanaugh and Fellbeck drove this point home when they discovered that adult Siboglinidae use both symbiosis and chemoautotrophic bacteria.
That's so interesting, Grandma. What's the second finding?
Your initial question ties right back into the second finding, which is that all of the Siboglinids studied so far have bacterial symbionts.
Bacterial what?
Bacterial symbionts are bacteria living in harmony with other organisms or each other. It is assumed that we rely on endosymbiotic bacteria for nutrition. Realistically speaking, symbionts have only been confirmed in about 170 species, which is not really that many. In addition, there have been discoveries of unexpectedly different metabolic types of symbionts within Siboglinids.
I see. So what is the final observation, Grandma?
The third and final finding is that Siboglinids comprise a monophyletic clade. Evidence suggests that the last common Siboglinid ancestor was likely either symbiotic or pre-adapted to symbiosis. This observation provides a strong example of the host-symbiont relationship at higher taxonomic levels. However, there is an exception to this observation. Frenulates are phylogenetically distinct from other Siboglinids, which doesn't support the hypothesis that Siboglinids make a monophyletic clade.
So, Grandma, how is all this information useful?
Well, sweetie, these 3 observations can help us narrow down possible explanations for our evolutionary history. We are still uncertain about the time frame in which we divided from our relatives.
So after all these observations, where exactly do we belong?
Well, little worm, there aren't very many human experts, and they still don't seem to know very much about us in the grand scheme of things. In fact, we still remain unplaced on the annelid tree.
Why don't they know where to put us?
Good question. They know that we exist, and they understand our importance, but we are still hard to study, classify, and identify. The characteristics that define our family taxa are based on soft tissues, so it's difficult to study our fossil records. Lack of sampling and many other factors have also contributed to this.
So now that the humans know about us, what steps are they taking to classify us? All I want is to belong somewhere.
Don't you worry, little worm. Only a small portion, around 65,000 kilometers of our home on the continental margin regions has been explored. Further exploration and studying of us will lead to many new discoveries and scientific advancements. All we have to do is keep on swimming and wait.